Hi, in this video, I will be showing you problem number 23 of chapter 15, section 8. Evaluate triple integral over E, x square plus y square dv, where E lies between the spheres x square plus y square plus z square equal to 4 and x square plus y square plus z square equal to 9. So in this problem, we are evaluating the integral given over the solid, where the solid lies between two spheres. One is with the center at the origin and radius equal to 2, because this is radius square. The second one, the center at the origin, radius equal to 3. So let's recap the formula for changing the triple integral x and triple integral to spherical coordinates. How do you change from rectangular coordinates to spherical coordinates in a triple integral? Triple integral over E f of x y z dv equal to integral c to d and integral alpha to beta, integral g1 of theta comma 5 to g2 of theta comma 5. So the first limit is for phi, the second limits are for theta, the innermost is for rho. F of rho sine phi cosine theta, here note that x changes to rho sine phi cosine theta, then rho sine phi sine theta, so that's the change for y, and rho cosine phi, that is the change for z. Then dv changes to rho square sine phi d rho d theta d phi, where E is rho theta phi, where phi runs from C to D, and then theta runs from alpha to beta in the formula, and rho runs from g1 of theta comma phi to g2 of theta comma phi. We clearly notice that x changes to rho sine phi cosine theta, y changes to rho sine phi sine theta, and z changes to rho cosine phi. dv changes to rho square sine phi d rho d theta d phi. Now given here, the solid is between two spheres. As we said earlier, one is with center at the origin and radius 2, the other one is center at the origin at radius and radius 3. So writing E in spherical coordinates, we write E as r theta phi, where r ranges from the lower value of radius to upper value of radius, which is 2 to 3. So 2 less than or equal to rho less than or equal to 3, and theta running from 0 to 2 pi, and phi running from 0 to pi. Now we are going to integrate x square plus y square. So we have to compute what this x square plus y square is in spherical coordinates. So to evaluate the integral, first we have to work on the integrand. X square plus y square equal to rho square sine square phi cosine square theta, plus y square is rho square sine square phi sine square theta. In these two, rho square sine square phi can be pulled out. So rho square sine square phi times cosine square theta plus sine square theta. Rho square sine square phi. Now x square plus y square becomes rho square sine square phi. So we have got the integrand value. Now we'll evaluate over e x square plus y square. The triple integral over e x square plus y square dv is integral 0 to pi. Those are the limits for phi. Then integral 0 to 2 pi. Those are the limits for theta. Then rho from 2 to 3. The integrand is rho square sine square phi. Then dv in spherical coordinates is rho square sine phi d rho d theta d phi. Rho square sine phi d rho d theta d phi. This is the expression for dv. Now all these functions are separable functions. So we can separate them for one for phi, one for theta, one for rho. So phi running from 0 to pi sine cube phi d phi, integral theta running from 0 to 2 pi d theta, rho running from 2 to 3, integral rho to the power 4 d rho. So the first one we will call it I1 for the time being. We have to evaluate that separately. The second one is 2 pi. Third one is rho to the power 5 over 5 between the limits 2 and 3. I1 times 2 pi. If you evaluate this, it is 3 to the power 5 minus 2 to the power 5 over 5. That will be 243 minus 32 over 5. Then we have to evaluate this I1 and we will take it up on the side. I1 is integral 0 to pi sine cube phi d phi. Phi is the Greek letter here. So I1 is integral sine square phi sine phi d phi. There are several ways of integrating this. We will write sine cube as sine square times sine. Then sine square phi by Pythagorean identity can be written as 1 minus cosine square phi sine phi d phi. Substituting cosine phi equal to u, we get negative sine phi d phi equal to du. Because we are changing the variable phi to the variable u, we have to accordingly change the limits for u. So the limits for u becomes 1 to negative 1. Now if we evaluate, I1 is integral 1 to negative 1, 1 minus u square negative du. Taking into account of this negative sign with the integral 1 to negative 1, we can switch the integral. That will change the integrand to positive. So we get integral negative 1 to 1, 1 minus u square du. On integration, it becomes u minus u cube over 3 between negative 1 and 1. Going back to the previous step, step A, and substituting this I1 into step A, we get triple integral over E x square plus y square dv I1, which is 1 minus 1/3 plus 1 minus 1/3 times 2 pi times 211 over 5, which is 1688 pi over 15. In the next section, we will be doing the change of variables applied to triple integrals. Hope this video helps.